Since the Industrial Revolution, we've relied heavily on fossil fuels to power our planet. But our thirst for energy is draining our resources and destroying our environment. The release of carbon dioxide into our atmosphere when we burn these fuels is the main contributor to climate change and air pollution. But we can harness the alternative natural power our planet provides. By using renewable energy sources, we can protect our environment and ensure energy security for the future. Various forms of renewable energy can be found everywhere in the UK, and Cornwall is blessed with more than most. We already generate about a third of our energy from renewable sources, mainly wind and solar. With the help of funding from the European Regional Development Fund and Cornwall Council, we are closer to unlocking the geothermal potential of Cornwall with the United Downs Deep Geothermal Power Project. By 2030, Cornwall hopes to have 100% of its electricity generated from renewable energy sources, with geothermal adding to the energy mix. But what is geothermal energy? Geo means earth, thermal means heat. Therefore, geothermal energy is heat from the earth. And the deeper you go, the hotter it gets. In areas close to tectonic plate boundaries, geothermal energy has been used for decades to provide renewable electricity and heat. These places have a higher geothermal gradient, making it easier to reach useful temperatures with shallower drilling. Drilling is often the most significant cost in a geothermal project, so having high geothermal gradients is important for commercial geothermal developments. Iceland's a good example of a country which uses this conventional type of geothermal energy. It sits on top of the mid-Atlantic ridge and is very volcanic. Underground reservoirs of steam and hot water are tapped to provide a quarter of the country's electricity and more than 80% of its heating needs. Geothermal energy can also be used in places that are not near plate boundaries, as long as the geothermal gradient is still high and the rocks have enough permeability. Cornwall has a long history of geothermal exploration, and it's been known for many years that the rocks under Cornwall are hotter than anywhere else in the UK. The geothermal gradient is much higher here than the UK average, thanks to the composition of our granite. The radioactive decay of uranium, thorium and potassium isotopes makes it naturally heat producing. Cornwall has a lot of granite, and most people are familiar with places where it outcrops at the surface. Bodmin Moor, St Austell, Carmanellis, Land's End and the Isles of Scilly. These outcrops are joined together underneath the surface by the Cornubian batholith, a huge granite intrusion which stretches for the entire length of the county. Cornwall owes much of its mineral wealth to the intrusion of this batholith, as hot fluids escaping the granite carried and then deposited tin, copper and other metals into lode structures in the surrounding rock. Throughout Cornwall's mining history, certain geological features in the mines, the cross courses, were known to be highly fractured and very wet. In fact, these features belong to a family of faults that cut across the county from northwest to southeast, and they represent permeable targets that have the potential to host geothermal reservoirs. The United Downs Deep Geothermal Project aims to intersect one of these targets, the Porthtowan Fault Zone, which extends from Porthtowan on the north coast to Falmouth on the south coast. To intersect the Porthtowan Fault Zone at the right temperature, we have to drill two very deep holes called wells. First, we will drill the injection well to a depth of 2,500 metres. This will allow us to confirm the geometry and nature of the fracture system in detail, before drilling the deeper production well to a depth of 4,500 metres. The wells will be vertical to start with, but then steered towards the southwest to intersect the fault zone at the optimum angle and depth. They will be lined with steel casing over most of their lengths, leaving just the deepest sections open to allow water circulation through the reservoir. We expect the water temperature at the bottom of the production well to be about 190 degrees Celsius. It will be pumped to the surface and pass through a heat exchanger before being put back into the reservoir through the injection well. The system will operate as a continuous closed-loop circulation, mining heat from the rocks for up to 25 years. The heat energy extracted at surface will be converted to electricity in a small pilot power plant, capable of producing between 1 and 3 megawatts of electricity. Geothermal energy has many advantages over other energy sources, even some other renewable sources. It's clean, natural and sustainable. It has low impact above ground and uses only a small amount of land. It has low or zero greenhouse gas emissions and can provide both electricity and heat continuously. The United Downs Deep Geothermal Power Project is an exciting opportunity for Cornwall and the UK. Not only does it present a chance to realise the county's true geothermal potential, it's a positive step towards a greener and more sustainable future. To ensure that our Earth remains a clean and beautiful place, we need to shift to renewable energy. So it's wonderful to think that some of that could be coming from right underneath your feet. Cornish geothermal energy.